So welcome back to Genknown tutorial, and for today's video we will going to talk about the derivative in parametric form. This topic is under chapter 7 of differential calculus by Feliciano and Uy. Okay, but before we proceed, don't forget to click the subscribe button and also hit the like button and the notification bell for you to be notified in our latest and future uploads. Okay. In derivatives in parametric form, the derivative of the first order in parametric form is given by dy over dx. This one, dy over dx, which is equal to the derivative of y function with respect to t over the derivative of x function with respect to t. So while in the second order in parametric form, or the second derivative in the parametric form, it is expressed as the derivative of dy over dx with respect to x, or we can say that it is also equal to derivative of dy over dx with respect to t, okay, multiplied by the inverse derivative, or multiplied by the inverse of the derivative of x with respect to t. Okay, furthermore, for you to fully understand the topic, let us all have an example. Let's say example number 1 under the exercise 7.1. Okay, in example number 1, or in the problem number 1, we have x is equal to t cubed plus 1 and y is equal to t squared plus 1. The first thing we should do here is to derive each function with respect to t. Since xt is the only variable here and yt is the only variable in the second function, so hindi natin kailangan i-derive ito with respect to y or with respect to x, and unless may ibang variable na naka-indicate dito. Okay, the first thing is deriving the x with respect to t, so that is equal to dx over dt is equal to the derivative of t cubed plus 1, which will give us 3t squared. Okay, for the second function, we have y, or derivative of y with respect to t is dy over dt is equal to the derivative of t squared plus 1, which is 2t. Okay, so based on the parametric form, or first derivative in the parametric form, dy over dx is equal to dy over dt over dx over dt. Okay, so we will substitute this value as indicated here. So dy over dt is equal to 2t, while dx over dt is equal to 3t squared. Okay, simplifying this form, we can cancel out dt here, 1t only. So this is also equal to 2 over 3t. Okay, for the second derivative under the parametric form, we have d squared y over dx squared is equal to derivative of d over dt dy over dx multiplied by the inverse of dx over dt, or it is expressed as dt over dx. Okay, so based on this, we should derive the first derivative with respect to t. So d squared y over dx is equal to the derivative of 2/3 of t, so that is equal to negative 2 over 3t squared multiplied by the inverse of dx over dt. So the inverse of dx over dt is just dt over dx is equal to 1 over 3t squared. 1 over 3t squared. So overall, the second parametric derivative of this given function is equal to negative 2 over 3 multiplied by 3 is 9. T squared multiplied by t squared is t to the 4th power. So overall, this is the final answer for the second derivative, and this is for the first derivative.